Now that video is the last video in the 5-video sequence on handling big data with PCA. Not surprisingly, being the last video, it also means it summarizes a couple of takeaways. The notation it uses has been introduced already in one of the previous videos. So here's my first takeaway. If XDM is the demeaned matrix of the original T times K data, then X tilde dm coincides with the following expression. And note that X tilde dm represents the matrix of risk factors, or you can also say of the principal, these are the principal components. Notice that I'm using here explicitly the D index to highlight that you've sorted the eigenvalue and eigenvector matrices in descending order. Now my second takeaway. To explicitly highlight the relation to principal components, I highlight explicitly here that X tilde dm can be written as this matrix of PCs. Note that the first column is the time series of the most important risk factor in terms of variance explained, while the last column represents the time series of the least important risk factor. Now my third takeaway is that the covariance matrix of the PCs is simply the lambda. Fourth, if you take the ratio of lambda I divided by the sum of all lambdas, that quantifies the percentage of variance of the original data that is captured by the ith principal component. My fifth takeaway would be that it's good practice to work with as many statistical risk factors as are necessary to capture roughly 95% of the variance of the original data. You could then apply any parametric or non-parametric time series model to each risk factor to model its statistical characteristics. It's especially convenient to use a parametric model that scales linearly, such as any type of Armagh models for which we have videos already out.